And we're live. Hello. Welcome to this session called Sailing Modern Java. How's the conference? Very good. Very nice. I like that you... the coffee's good? The nice thing about coffee is that it's available all the time, right? So it's, yeah. Good. So this talk is scheduled for 45 minutes only, which means we're not going to go for any deep dive, right? Unfortunately, there's just one slot, 3/4, so we'll be sailing modern Java, meaning I will be like... Usually we'll stay on the surface, just whenever we can, we'll take like a look deeper, but that's gonna be it. Quickly about myself, if you have like an urge to follow me on social media, you can do so on Twitter, Mastodon, Blue Sky, LinkedIn, whatever. I'm not on Instagram as far as I can tell. I work as a software gardener. If you don't know who software gardener is, please read a fantastic book called Pragmatic Programmer. I'm also Test Containers Community Champion, and I also work as a trainer from time to time. And every now and then, when I have time and something to share, I put it on my personal blog page called softwaregarden.dev. Yes, so this is me, and I've realized a few days ago, this is me for like last 20 years. I've been doing Java for 20 years, right? So even when I go on holiday, Java is like somewhere in the background. This is how it works for me. Just one question. We have still like a few people standing in the back. Can you raise your hand if there is like an empty seat next to you, so they can go and like, yes, thank you. Little warning, everyone can make mistakes. I can also make a mistake, especially when I'm stressed back on live stage and I slip funny words which don't quite match the context. Yes, so it's a human thing to make mistakes. Verify on your own. Don't trust anything, especially if you're watching us on internet, right? Yeah, so Java 21, which got released like more or less a month ago, and even like a small or minor update version has been released like a week ago or something. So it had 15 JEBs in total, and you can go and follow either of these links for this release notes or this release notes, and there was like a nice like a changelog on what happened, what was added, what was removed, and so on. The purpose of this talk is that instead of reading it for 45 minutes, you'll be attending this talk, right? So this is the whole idea behind it. So as you can see, unlike Java 19 or 20, we have not only previews, we had things that were delivered as standard feature, as a regular feature. So of course we have previews, we have like string templates, singles collections, and all these nice things listed here. And there is, of course, more. As I guess many of you have heard about this 444, which is virtual threads, right? One of the most important things in modern Java. And of course, there's like these scope values and also like other changes. So I think I gave you this link to release notes, right? And this is the list of the changes. So thank you very much. That would be it. Not really, no. Yes, before we dive into technical stuff, there's always this question like, okay, let's go through this quickly. Who's using Java 21 in production? 2, 3 hands. Okay, who's using Java 17 or above in production? Nice, I'd say like 40%. Okay, who's using Java 11 in production? Okay, so there's more Java 17 people. Okay, who's using Java 8 in production? Still a handful of hands, like Java 7 or Java 6, like anyone? Don't be shy. Don't be shy. We're with you. We'll just hug you. Yes. So the thing is, people ask me this question when I do like consulting or training session, like, shall I? Because fortunately for us, Java 21 is LTS by almost every vendor, or if not every vendor, right? But the question is, shall I stick to the newest Java version? Like in the next 6 months, right? In March, there's going to be Java 22 released, and the question is, shall I jump and start using Java 22 or stick to Java 21, right? And I would say, what would you say? I would say you should rather update to Java 22, unless you have valid reasons not to do so. Who knows what LTS stands for? Long-time support. Okay, who's paying for the support? Raise your hand. Exactly. No one, right? So, if you don't pay for the support and there's nobody to pick up the phone and say, hello, what can I do for you? How can I assist you, right? You're basically, you don't have the benefits of LTS anyway. So why don't you just upgrade to Java 22 and Java 23 and so on? Okay, that's the thing. And I'll show you what it might be important to sort of serve this wave of new Java releases, okay? Of course, sometimes there are good excuses, like there's like this key dependency, like library framework, you can't really upgrade past it because it's a core of your business, it's core of your domain, and you have to wait until like they upgrade it or something like this, okay? But else than that, I think if you don't upgrade frequently your Java versions, it means you don't like having money. This is what it basically means, okay? Yes, so LTS doesn't mean banana soft or monkey soft or like inferior version or untested version, okay? It's just a solid, robust version. Technically, there's no difference when this release train goes from the station, right? Every 6 months, the LTS applies only to the support, as the name says, right? So LTS stands for support, long-term support. If you don't have support, it has like no value for you to stick for this LTS version. Okay. In short, what we have in is Java 21. We have new language syntax, standard and preview features. We have, of course, big changes to concurrency. We can now process data, especially records, in a different manner. There's like a nice native stuff, like native memory calls, native calls and handling native memory, and also other things like ZGC, sequence collections, sunsetting Windows 22, and deprecated dynamic agents, and so on and so on. So, preview features. Who's been using preview feature? Okay, a few brave hands. Okay, so it's just a feature that that may change. Okay, so that's why you have to opt in for it. You have to go basically, as this JEP specifies, go for -- enable --preview when you compile, when you run new stuff, and so on. So therefore, it might be not wise idea to use them if you don't master the production. Okay, if you run stuff on your own, then it's like doable, maybe not encouraged, but like it's also like discouraged, sort of like gray zone. But when you when you create software and your clients are running it on their premises, maybe preview features aren't good ideas. But many things that I'm going to show you today are preview features. So if you want to run them in your IDE, on your machine or something, you need to make sure that these are enabled, right? And I describe it here, how you can enable them and how what would they do, how they're written to class files and whatnot. Okay, so changes to concurrency. The issue is that platform and more OS threads can be slow to create and costly to create, right? So back in the day, when we wanted our systems to do something like concurrently, like two things like at the same time, we were forking new processes, and then we realized that this process is too costly, right? It takes too much time to spin a new process. There was also a problem like sending data between these two processes, right? Because they didn't share memory and so on. So we went for operating system threads, and we thought that was a good idea. And it was a good idea for like a relatively short time, because then we again reached the same problems, that they were too heavy, too costly to create. So we started using different things or different approaches, right? And the issue is that there's also a limited number of threads you can have. So you can have like a few dozen thousand threads in your machine or in your server, and that's pretty much it. So if you want to have this thread per request model, right, and you have, for example, tens of thousands of requests coming to your system every second, you can't have, or you can't rely on this thread per request model anymore, because fun fact, you won't have enough threads given to you by the operating system. And who's doing reactive? Okay, keep your hands raised. Keep your hands raised. Okay, who can debug and troubleshoot reactive stack? Okay, just a few wobbling heads. Without help of IDE gluing the stack traces. No one, including myself. Exactly. There are smart people who can do that, right? Big brains. But for us mere mortals, this might be too much, right? So therefore, reactive is nice when you just do this hello demo or hello world stuff from the tutorial. But once things get really screwed up and complicated, it's not so easy. It's not trivial to debug and troubleshoot. Therefore, this model with threads might be easier, right? And what we also don't have, we don't have this we don't have this async await model like our JavaScript friends are, or full stack developers, right? So maybe in Java we'll have something like that's an equivalent of this model. So here they come, virtual threads from Project Loom, and people are asking this question because Java 21 was released. Is this the biggest change since introduction of Lambda in Java 8? And there are basically two groups of people. One group of people says, yes, this is the biggest change we see in Java since Java 8, since introduction of Lambda and streams and whatnot. And the other people say, no, sorry, it's like, no, this is even bigger. This is the biggest change that we've seen in Java for many, many years, right? So it's up to you to answer this question. But what are these? These are like standard feature now. We also have structured concurrency after incubating twice, as it's in preview feature Java 21, and we have scoped values, which are also incubating or like in preview. And the cornerstone of these changes to Java concurrency are virtual threads. And the idea is to not reinvent the wheel, but keep the threads concept, okay? Because first, it's used by the libraries or frameworks that were written for, like, I don't know, 20-something years, right? And the other thing, that we are used as developers, as a community, to threads, right? We know how to use threads. I mean, Javie was showing you things about, like, logs, about synchronization, and so on. So the idea is not to trash it and go for something new, but to reuse the mental model we already have. And to give you an idea, it's pretty much like with cars versus taxis. So, and like we're in Krakow, this is like a big city, and we know what it means when everyone wants to drive their car because it's like a cold, rainy day, right? It means traffic jam, because fun fact, the streets are not made of rubber, so we can't stretch them to get more cars in, right? So our model, like passenger per car, isn't working anymore. Just as a request per thread isn't working anymore. So what we can do instead, of course, there are many solutions, but one of them is, for example, car sharing, where you have like taxis or Uber or Bolt or whatever. And then the idea is you don't need the car when you're sitting here. Right? You don't need your car when you're working in your office. You don't need a car when you're watching a film in cinema. You just need your car when you're commuting from point A to point B. And then the idea is you just go for this app in your smartphone, or you just give them a call, whatever, and then magically a car appears with a driver, and they drive you from point A to point B. And then you get out from this car, and then this car can get or respond call from somebody else, right? And then they will drive these other people. So the idea is, with much less hardware, we can still serve the same amount of passengers. And this is the idea behind Project Loom. So we have now virtual threads, which are like these passengers, right? So whenever there's a need for CPU computation, they just call a cab, which is called platform thread, or carrier thread, to be precise. And the carrier thread appears, it drives the virtual thread from point A to point B. And then when the virtual thread needs to do some waiting or some I/O operation, it mounts or releases back to the pool this carrier thread, right? So this is the idea. This is how it works, more or less. And they are cheap to start, right? They're much cheaper to start. They just need 300 or 400 bytes on heap. And just as I told you, they're carried by this platform operating system threads under the hood. Because there's this. What virtual threads are good for is waiting or I/O, right? Because they don't do that, basically. They just get out from this taxi, and then the taxi can transport other people. And they're always daemons with normal priority. And there's one thing you need to remember. There are a few things you have to remember, right? But one of them is there is no magic switch to turn the threads you currently have in your Java application into virtual threads. There is no -D switch. There is no -XX switch, okay? What you have to do, you have to go through your source code, and you need to change it and say, okay, in this place, instead of executor, thread factory, or thread, I'm going to use virtual equivalents, right? And of course, there are frameworks like Spring, like Quarkus, and what else, that will basically, they have switches. So that there you can switch like between, okay, I want to have like this good old platform threads, or I want to have virtual threads. But they know that what kind of payload that is, what kind of usage scenario that is, so that switch makes sense then, but there's no such switch in Java. So you have to go for something like this. You have to go for thread or virtual. You put runnable here. This could be, of course, Lambda as well. And then if you need, you can go with this builder pattern. You can set like a name, whatever, and then you say start when you're ready, okay? And when you have something relatively short-lived, for example, or something trivial, you just go start virtual thread, and that's it. You provide just Lambda, okay? So basically, you trade one dot for one extra character. And there is this new executor, and its name is, and this is important, thread per task executor. We'll get back to that, okay? So whenever you need, whenever you have a new task, this executor will give you a new virtual thread. And should you need factory, this is how you do that, thread or virtual.factory, right? This is how you change your your code to have this working. And just to give you like we don't have much time for demos, but like I need to show you like a demo or two. Let's try to do a quick demo. So I have like a oversimplified demo that will try what we're trying to do here. I'm trying to emulate that I'm working, and this emulation is basically only going to be sleep, and I'm trying to start given number of threads, right? So let me try to start 30,000 threads, and how I create thread right now is like I do it this old-fashioned way, which is still valid. It still works, like new thread job and whatnot. Let's try to run it, and let's see what happens. Come on. And see, every 5,000 threads, we see that this number of threads has been created, and current count, there was 30,000, so we've created 30,000 threads. Come on, come on. It's still running. Finished running like 15 seconds. Okay, now let me try 40,000 threads. So question is, can I have 40,000 concurrent threads given like by my operating system? And does it run? It still runs. Oh, it doesn't. See, it reached 30,000 threads, and then around 32, it just gives up because there is like, you see, basically not enough memory, blah, 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 like all the usual reasons why you can't get like yet another operating system thread. And what we can do now here is like we can switch, so say, because what this, let's say we are calling, we're making a network call, right? So now I'm doing like the sleep or something, which is, you shouldn't be doing this in production, but let's go for virtual threads, right? And see if this code will run with virtual threads, and it does. And see how quickly it did it. So see, these virtual threads are really cheap and fast and easy to start, right? And now we're just waiting these 10 seconds because we wait for the last thread to finish. That's why we had, so this is the overhead for creating these 40,000 threads. And you may ask yourself, how many threads can we create? Can we create, for example, like 100,000? Or how about creating just 1 million of threads? Let's see if it works. And it seems it does work. So I can have on this 4-year-old average PC-grade machine, I can have 1 million of virtual threads, right? So provided these threads are doing a lot of I/O and not a lot of CPU, I can have, see, 100 million threads. So this is when they excel. This is when they're needed. Okay, but this is what you have to remember, that virtual threads will not magically squeeze more juice out of your CPU. If you have application that it's already CPU intensive, just switching to virtual threads won't give you large benefit, if any, okay? Virtual threads are good when your application waits, when your application does a lot of I/O, like calling network services, calling databases, calling message brokers, doing something with files, or something like this, right? When you're just looking for a next Fibonacci number, you won't get any benefit from virtual threads, okay? That's why I think there is this global switch, because you as a developer, you know what your system is doing, what's the actual use case, right? What's the scenario? You can profile your code, like Jarek just said, right? And so on. So then you know, so okay, for this executors or this thread pool, it makes sense to go for virtual threads, but not for this other thing, right? So for I/O, virtual threads are super good. For CPU-related things, virtual threads are kind of like no huge benefit, if any. So many people tell you virtual threads are great and fantastic and virtual threads, like, just go for them, they're awesome. But there are also things you shouldn't be doing with virtual threads, right? So as I mentioned that, you shouldn't be going for virtual threads everywhere, right? Because it's sort of like pointless, but also you shouldn't reuse them, right? They're cheap, they're easy to start, they're lightweight. So whenever you have a new task, you just start new virtual thread. Hence the name of that executor, new thread per task, right? You shouldn't pull them. So we used to pull threads, for example, to handle back pressure and so on. So we shouldn't pull virtual threads. We should have just different mechanisms to handle back pressure if you just want to, for example, forget about reactive stack and whatnot. And the last thing you should have been doing, I mean, there are many things, but last I mentioned today, is pinning. And pinning, when we go to this taxi situation, is this. You go to the cinema, and you tell the taxi driver, stay here, keep the engine running. When I will get back from the cinema, right, I will pay you for that. The thing is, the car is running, the engine is running, right, it's consuming fuel or other source of energy, and other people can't use it, can't call this taxi. And this is called pinning. And when does it happen? It happens, for example, when you call I/O operation inside synchronized block or method. So you shouldn't be doing that. And how to detect that? You just go for this flag, trace pin threads, or you watch for Javie events, right? And then this is how you can tell that you haven't been, that your application is not misusing virtual threads. Right? And I have like an experiment. For example, if this is your system and it's making a call to another microsystem, you can just extend or create like a faulty network using toxic proxy, using, of course, test containers and whatnot. And I described it in my blog page. So I encourage you to go there. If you need to verify, like you have like a legacy system and you want to try if virtual threads make sense for you, you can just easily verify it with like a few just like a relatively few lines of code, right? In a beautiful integration test. Okay, there's another thing, structured concurrency. It's about having better idioms for multi-threaded code. And it's to help eliminate our thread leaks and cancellation delays. And quite fortunately, we have experts here in this room, experts for completable futures and whatnot, so they will help us in this presentation, perhaps. And it's also right now about not replacing interruption with cancellation. In the future, we might see. Come on, come on. Very nice. Okay, good. Yes, because when they take you these pictures, you always have these pictures with the open mouth, like, and it doesn't look good on like Instagram or whatever. Okay, so this is how structured concurrency may look like. And this is the idea. We create structured concurrency in here, right? And this is shadowed on failure. So whenever, because we have a task that can be divided into subtasks, okay? And whenever one of these subtasks fails, we want the whole thing to fail, basically. So we have this scope and we have like this name service. We need to get names and we have to get scores from the score service. And so we create two subtasks, right? Name subtask and score subtask, and then we join. So this now will happen, like each of these tasks will get its own virtual thread, right? And will happen independently. And then we wait here until all of them complete. And then, of course, we can add this, throw it failed. And then like pretty much like with completable futures, we can get these names and scores, and then we can combine them, merge them, whatever. The benefit is, if you do that with futures, and you forget to like subscribe this futures to each other, right? For example, let's say this names tasks or names future failed, then this thing will continue and we'll wait until it completes, right? So we'll be waiting needlessly, despite this task has been like this task has failed, and for example, we can like cancel the whole task, right? And this is what structured concurrency gives us. If one of these subtasks fails for this shutdown failure, then the whole thing is cancelled immediately, and you don't have to subscribe these subtasks to each other, because with just two subtasks, it's relatively easy, right? A listens to B, B listens to A. Do that for 4 subtasks. And that's what we have when we call it callback hell, right? So this callback hell is hidden from us behind this shutdown on failure structured task scope. Okay, yes, and we have this free cancellation within the 3. That's important. There are 2 structured task scopes by default. First is like shutdown on failure, when you've seen that, and the other is shutdown on success. For example, you have user ID and you need to translate it into username, right? And you can do that using 3 services. You have like a very efficient by small cache, you have like a slightly less efficient cache, pretty much like CPU, and you have a database, right? And instead of asking them sequentially, ask the first cache, no answer, then ask the other cache, no answer, and then ask the database, you can ask them 3 at the same time, all of them. And then whoever gives you the first answer, you may say, okay, I got my answer, it's a success, everybody else, like, stop doing what you're doing. Okay? And of course, you can implement your own task scopes if you need to. Don't forget join or join until. If you forget about them, like in this scope, you'll be given basically an exception. You'll face an exception. So then you'll know, aha, I've forgotten to add this scope.join after I created all of these or started all these subtasks. So this, if you think about it from a different angle, looks kind of like async await, right? Basically. Yes, and now we go for scoped values, which are like one way immutable thread locals, I call them, and they have bounded lifetime. And the nice thing, unlike like in thread locals, is that this lifetime span can be seen in code. And that's what's really cool about them. And that simplifies the reasoning and also improves performance, because let's say I have this 1 million virtual threads, right? And I have just like a simple string that doesn't change, right? And I put it as a thread local in every of these threads. Then what happens? I create, okay, so like string is maybe not a good idea because we have string deduplication and whatnot, but let's say we have like other objects or something like this. And then it will be copied and copied and copied 1 million times, right? And the idea is, if you just read it, why not just have one copy, which is read-only? That's the whole idea, right? Thread local doesn't change, it stays the same, it's not even deprecated, it's still needed in many situations. Okay, but how? Okay, I won't zoom it in. How does it work? So, pretty much like thread local, we create this new scope value, right? And it's like the clearance level or the access level. You need like different levels of access to, fun fact, access some facilities, for example, like think log for shell. And then I can say, for example, I get the level from request from like JWT, from like other authentication tokens, I don't know. And then you set clearance level, right? Given, like, for example, from request, should we handle HTTP request? And then we say, I mean, this scope value looks pretty much like optional. You can say, for example, or give me the default, the guest level, and guest can't do anything, basically. So if the level permits, I can do, for example, I can call external third-party system, I can call my database or whatnot, and if it doesn't, I can say like an error, like insufficient privileges or something like this, right? And then I can then, for example, to avoid log4shell situation, I can say when I just need to log the progress, I'm missing like a one. Yeah, okay, forget about it. Then I can say security level is no access level, because this is like DB call and this is like a third-party system call. But just for logging, I don't need any. I can just clean it, right? So see that this thing is nested in this thing, and when I exit this scope and when I exit this scope is cleaned. Reverted, hence the name scoped value. This is a value that is set only for this very scope, not outside. And I can nest these scope values pretty much like matryoshka dolls, right? Yes, so this is like, if you have like need for read-only thread local, then you can go for scope values. They work nicely with structured concurrency. The thing you've seen before, like with subtasks, and there's either runnable or callable, should you need to have a result or not. And these wheres, as I told you, can be nested, right? Inside, and you can get deeper. That was it about concurrency. Now we go for processing data. So record is a standard data carrier. Who's using records in their code base? Okay, there are less hands than Java 17, I'm surprised. Okay. Current syntax in Java might not be easy if your flow is data-driven or like data-first, right? Because it might look like this. You have this object, and we check if this is an event. And this is already simplified, because before Java 16, we would need to do the casting here, like create event E, cast object, or like event O, whatnot, right? So, and then I need to check if this, let's say I have this getter or accessor, if the value given here is like matching certain criteria, and if only if it does, I'm doing something else, I'm doing something else. And this is a lot of ceremony to do a relatively simple thing, like no big deal, right? So here we have now pattern matching for switch, and it's doing something, pattern matching for switch and record patterns, right? And also unnamed patterns and variables. And the nice thing is good old switch remains the same, so you don't need to change your code or anything, like it will behave exactly as it behaved before, but now we can do more stuff inside your switch, right? Switch instructions and switch expressions. So now we can see this object is, this version is an object. It's an object. It's not just a string, a number, or boolean, or enum, right? It's an object, and now I can check. I can check if it's null. And if it's null, I can do something. I can throw my own exception, or I can say like, oops, like, or present default value or whatever. Then I can use so-called guard. So I can say when this is an integer, but also when this integer is at least 17, then I'm going to give you this result. When it's just an integer, I'm going to give you this result. And then I just by default, I'm going to give you oops, right? If it's something else that it's not now. So as you can see, instead of like a batches of ifs and elses and whatnot, I can go for this simplified syntax, right? And this is a standard feature of Java 21. So now switch can be more null-friendly, handles objects, not just primitives. Dominant cases aren't allowed by computer. In previous example, I couldn't be using greater than 17, for example, below just integer, because when it's integer, it always like falls in first, right? Because it dominates the other case. Or things like serializable and string. You can't have serializable first and then string, because you won't be able to reach the string, because every string is serializable, right? Cases can contain guards. Sealed classes don't need defaults, and pattern matching doesn't work with primitives, right? So we just need to have these auto-boxed types. Both switch expressions and switch instructions support this, and pattern matching, of course, doesn't allow fall through. It wouldn't make any sense to do that. And now we go for record patterns, and for example, we have a record which is a value, just keeps a double value inside, so it's sort of like a wrapper, and then we have a complex number. And if you didn't have like a algebra at university, think about it like a two-dimensional point, okay? And then this complex consists of two values. And then I can do this pattern matching. I'm given something, and I want to check if this something is a value that inside has like the lowercase double, or if it's like a complex, right? And then if it's complex, I can say it's a complex of a value of a double and another value of a double. Sorry about the mixed coloring, but it's JavaScript plugin doesn't handle this new Java syntax. What matters is, see, I don't have to just match it and then go just the ... to get this. I just matched it, this V here, and then I can just use V here. Right, because it got deconstructed. Like, think of it like the opposite of a constructor, right? What happened here. And I can just nest it. I can go deeper and deeper, see? And here I don't have to go for complex.value or complex.real.value. I can just go for R, and that's it, because it got matched and deconstructed here, okay? Very, very, very much nicer. I mean, Scala people, Kotlin people, and functional programming people already know that, but now we also have it in Java. So these record patterns allow deconstructing records, with nesting, of course, and no other types for now, so we cannot write our own unapply method. And it works with ifs, and it works with switches. And the last thing in this gang is unnamed patterns and variables. So sometimes, for example, you care only about part of this record. You don't care about the whole payload, just part of this record, right? So then you can skip, or you can just interested if it's just a record, for example. Then you can go for this unnamed pattern, or you can go for unnamed pattern variable. Then you care that this first thing, for example, is an integer, right? But you don't care about the actual value. So single underscore was banned in Java 9. Now it's reintroduced, and it has a different meaning, meaning I don't care what's inside. Basically, I ignore it. I explicitly ignore it. And of course, we also can have unnamed variable, and it looks like this. If we care if this complex in its real value is positive, I can do this partial matching, sort of. So I can say, okay, this value is like in a double R, and I check, see, I'm using these guards, that R is positive, right? And I totally ignore this imaginary part. I don't care about it. See? So I ignore this, and then I say, yeah, this complex is like real positive. And this is what matters. So as you can see, now think about it, try to imagine this code using ifs and using underscore ignore and everything like this. So it doesn't give us like any more powers, it's just now we can handle data in more concise way. So we reduce noise to signal ratio, okay? So these are useful for skipping irrelevant parts or in matched records. We can use them in for loops. You can use them in catch, right? So we can go just now for underscore when it's an exception, and we now just jump for native stuff because there's more from Project Panama. And as I mean, who has this fantastic fantastic Spanish friend called Manuel? always be friends with manual, right? Do what manual tells you to do, of course. And people didn't read the manual, which was pretty obvious because the name of this class is unsafe, right? But what can we unsafe? Like, okay, what the hell? We'll use it anyway, right? And then, fun fact, it meant trouble, right? So the issue currently is that native stuff can be really unsafe. And it comes to like time and range and threads, so we can have like range leaks, thread leaks, and all those sorts of like headaches. It can be tedious because we have to generate all these stub files, all these header files. We need to synchronize .h files with Java counterpart and whatnot. And it's also like limited. For example, using byte buffer, you can't have more than 2 gigs of memory because index out of range exception or something like this. And it also can be slow, or in other words, it could be faster or significantly faster, right? So we want to have new things with performance at least as of GJNIs, maybe even better. So here it comes, foreign function and memory API. It's a third preview feature after being incubated, I don't know, like 5 times in the past. And vector API, which is 6th incubator in Java 21. And what are the building blocks of this foreign memory API and whatnot? So we have memory segment, which can be an array. It can be like a native chunk of memory, whatever, right? And then we say that it has an address. So it starts at this address, and then we have a layout. So it says, for example, it consists of elements, and each element has this layout. So like in programming, like in C, we can say it's a structure that has 3 fields. First field is like a, for example, long. The second field is integer, and the third field is like yet another structure, and so on and so on. So instead of just calculating the bytes and bits, you can just say, give me like the substructure from the second element. Because the whole thing knows the layout, it can give you that, right? And Arena provides boundaries for time and thread. It's very nice for a try with resources. And this is how this code may look like. Let's say we want to have 10 integers, 10 Java integers off the heap in the native memory. So we can go like this. I say this is my sequence, or my layout. Sorry, it's going to be a sequence of 10 elements, each element being Java integer. Right? It's one of the ways. And then I create an arena that is confined. Confined means only this thread will be able to access or play inside this arena, no other threads, right? And as you can see, I'm using it in this try with resources, meaning when I reach this point, it will be cleaned or released back to the operating system, right? And then I say I want to create a segment, right? And the segment is inside this arena. Just create me this layout, right? And then I just do a simple loop, see? So I don't have like a magic number. This magic number 10 is only here in declaration of the layout. And then I can just iterate, and I can set elements, and I can get elements from this off-heap memory, right? So it's really easy. I don't need to have any C code, any stub files, anything like this. It's really all that's needed in Java 21 to play with native memory. And then, why do you need this native memory? You just need it, for example, when you do a native call, it's usually you pass some data to this native call, or you get some data from the native call. That's the whole point behind it, right? So we want to replace JNI with pure Java development model. So we will have support for C, at least these 2 architectures right now. In the future, this may get extended, and it may look like this. So we get like a native linker, right? And we get standard library, and then because I'm friends with manual, I know there's a function called getUID. So if I don't get this function, then I just want to throw an exception, and then I sort of prepare like the function description, right? So this is the result, these are the arguments and whatnot, like kind of like signature, and then I can create don't call handle, meaning from Java I want to call C. Right? I just make a like call down, basically. And then I call this, and this is the signature, and then when invoked, it will give me the user ID from this library. So I don't have to use any MX beans anymore and whatnot. And you, for example, can use this code if it's running as root or like a regular user. Because, for example, your application may decide, I don't want to run this as, or I don't want to be run as root. Right? There is like I have nice demo code for this, like, where is it? It's somewhere in the project, you'll find it. You smart people, you'll find it. Okay, another thing, generational ZGC. All right, so the standard feature, sorry, maybe it's not standard, maybe it's still like experimental or in preview or something. Yes, but the idea is, who's using ZGC or Shenandoah? So these are new garbage collectors, and the general promise is, so they've been lowering this limit, that they should have like stop-the-world pauses needed for garbage collection not longer than 1 millisecond. Okay, in the past it was like 2 milliseconds, now with one millisecond, and want to make them even shorter. So this is what ZGC was doing, and now there's like an extension to ZGC. It's called generational ZGC. So they want to keep improving the performance, and having these generations is seen as one of the ways of doing that. Still, the memory overhead should be quite low, like 3% more or less, that's the ballpark, and it should support heaps from hundreds of megabytes up to 16 terabytes. Who has a heap of size of 1 terabyte? Exactly, I don't have this problem as well. I'd love to have this problem, but I don't. And the whole idea is that now we'll map heap into regions that are old generations and young generations, and the theory behind this is this. When the object is created, it's a young object, and the chances that a young object dies and needs to be garbage collected are much, much higher than for the objects that are already old. So if you have two regions, young objects and old objects, you have to frequently check if the young objects are still alive, whereas for all objects, you don't have to do it as often. That's the whole, like, oversimplified philosophy, right? And the idea is that it should have minimal or maybe no configuration, and instead of using 4 bits ahead, it's using now 12 bits behind. So the thing is, if you have 16 terabytes of memory, and you have 64-bit architecture, to address every possible object in that heap, you just need or require 44 bits from that pointer. So we have 20 bits left. So we can keep or use this 20 bits for whatever we please, and the whole idea is generational ZGC is using 12 of those bits to just calculate and do stuff concurrently, because this is like concurrently compacting garbage collector, right? And it operates using load and store barriers. This is how you use it, right? In general, you always should set like a maximum memory limit, right? And then we say not only use ZGC, but also use generation ZGC, and that's pretty much it. And you might be wondering, why should I be doing this? So G1 is default garbage collector since Java 9, if I'm not mistaken, right? So I've created this piece of code that doesn't do anything but just create garbage. It's a terrible citizen, okay? But I use it for sort of benchmarks. Sorry, I don't know how to make that bigger, but I was running it, I mean, G1 using Java 15, and it took, or the longest pause needed by garbage collector, needed 113 milliseconds, right? So for 113 milliseconds, my application wouldn't be doing anything, but would be like frozen because of garbage collection, okay? So then we could go for ZGC in Java 15, and as you can see, sorry, here, the longest pause, the longest pause was 1 millisecond and, 1.13 milliseconds, 1.14, okay? So it was already 100 times better if you just switched. If your problem is that you have too long stop-the-world pauses, you should just go for ZGC or for Shenandoah, right? And then they said, we can still do something about it, and in Java 21 they introduced generational ZGC, and now as you can see, this longest pause is 30 microseconds, okay? It's not even milliseconds, it's microseconds. So if you have issues that you need like sub-millisecond garbage collection pauses, you should go for one of these two garbage collectors, basically. Else you're burning money. So that's it. And then you don't need to you don't need to recompile your code or whatever. You just need to install fresh new Java machine, okay, like new JDK, and just run your stuff on this newest version. And then you get the benefits from all of this. That's why I said maybe you should be surfing this wave, because this allows you to save money, basically, CPU and whatnot. Yes, and maybe the default behavior will flip in the future, meaning that the generational ZGC will be the default one. We have also now sequence collections, a standard feature. What does it do? Like if you're into functional programming, you should already know that some collections recognize the concept of like sequenced items. But for example, you might have like first in, first out, or like you have like a comparator like in tree set or something like this, right? So now the idea is that we have a common API for all of these. So we can say, for example, get first, or add last element, right? Or remove first element, and so on and so on. And This also means that we can now easily process these collections backwards. So if you need to process them from the end to the beginning, you can just call reversed. It will give you a nice view, and then that would be it, right? And you can like easily like process it in loop or something. Sorry. Oh. Okay, it was both of us. Okay, very nice. And you can go for this sequence collection, sequence set, sequence map, and so on. Let me just go here real quick. Maybe we shall see this. Do we see this? There should be like a nice diagram, or it's not here. Basically telling you where these new interfaces like sequence collection and so on, when they sit in this whole hierarchy of collections. And we have also string templates, and not much time, so I'll like really try to rush in. So string templates, do you know this? Is it painful? Even more people, yes, okay. So how about this? Is it nicer? Is it less? You laugh, of course, right? Direct, yeah, of course. Like, so the whole idea is to have something for like interpolation of these strings, right? And some people say, but my language is already doing this, right? My language can already do that, be like Kotlin, Python, Scala, PHP, JavaScript, whatever you have, right? But then your language is also capable of doing this. So the whole idea behind string templates in Java is to do this without the risk of this, okay? That's why that's the whole motivation. Okay, so now, in every source file, you have by default imported this str field as a public static final, right? And you use it like this. Maybe in IDE it would be easier to see. Real quick, sorry. String templates, yes. See, so I have just variables here, first name, last name, just it can be an instant, whatever. And then I just have this str imported automatically. And here I'm using text blocks, but I can also use that in regular strings, right? And I use this backslash, in Polish, some call it wtyłczach, and then with this, in these braces, I can just go and say first name, last name, whatever, and this will basically create for me or interpolate for me this string, right? I can also go for a row, and so on. So there are different processors. This str is kind of like a default one, recommended one. If you want to decide when this string is interpolated, you can just go there for row and call interpolate on your own, right? Because str does it for you automatically. There's also fmt. If you're using printf or formatters, then you should use fmt probably instead of str. And you can create your own processors. And the whole reasoning is that, for example, database vendors might create their own processors. So in theory, you could have, for example, SQL processor dot interpolate the query, and then you won't have SQL injection, because this processor should be smart enough to detect that this will create like a SQL injection or something like this. We have unnamed classes and instance main methods. Who knows this? Everyone knows this. Everyone built it. Everyone was told, just go for this public class hello world and just go put public static void, and trust me, you need these string arguments. But teacher, what for? Just trust me, we'll get to that in a week or a month, right? Something like this. So the whole idea is to have something nicer. Yeah. So we don't need this wrapping class, right? We don't need this public static. We don't need these strings. We just need this hello world. And we still need main, because C-derived languages, and maybe that would be too much, because the new students would say that's like, after they stop using this, eventually they need to understand this, right? So that perhaps could be too much. But so this is like the bare minimum, and then you can just go and put whatever you need in here, right? Yes. We can omit this argument. The main method doesn't have to be public or static. It doesn't have to be inside of a class. Then the class will be created for us. And there is a precedence. So if you have two methods called main, worry not. There's a given strict order in which Java machine will check for these, right? Yes. Various stuff. There are more updates to G1, parallel, serial GC, and garbage collectors, right? So this is the reason you should be updating your Java every 6 months, because you get better garbage collectors, for example. There are like quite a few issues were fixed. Another reason why you should be doing this. See, this is the like list of fixes in Java 21. This is the list, and it has at least 5 pages, if not more. So it means if you're running Java 17 and if they weren't backported, and some of them weren't backported, right? You have them like in your application. Happy log for shell.j. Yes, okay. There is like new encapsulation mechanism for symmetric keys if you're into encryption. Some stuff got deprecated, so we're sunsetting now official builds for Windows 22. We're also preparing to disallow loading agents dynamically, so we need to be explicit about this. Okay, I want to have this agent, or I like want to allow list this agent, or something like this. Some stuff got removed, so it was never a good idea to call this suspend, resume, stop methods. Okay, but now they will throw you unsupported operation exception. And now in Java 21 we can't set like a source or target for Java 7. It's normal. 8 is like the new oldest thing you can use. And now, always, for every event, for every meetup, conference, talk, whatever, just let the organizers and the speakers know how it was, okay? So now it's your time to, you have on these badges, you go to this app, you can go and say, okay, I liked this, I didn't like it because this or that, you can do that, right? If you're watching us on YouTube, you can do 2 things. First, you can go and fill this survey. If you don't use this app, of course, you can fill this anonymous survey as well. And don't forget to hit the subscribe button and the bell icon, right? You can follow me on social media if you fancy into like IT insights, new Java stuff, or just poor life advices. If you would like to have a workshop, I can do a workshop for you, right? For like with Jax or with the companies or something like this. So you're more than welcome to contact me, like describe your needs or whatnot. If you need to hire me for something else like consultancy or having trainings of like some other technology I might know, of course you're more than welcome to hire me. These are the slides, and then all the links are inside the slides. So if you need to take a picture from this presentation, this is your time to take a picture. In 5, 4, 3, 2. I don't want to make any pressure, but okay. We over time. Sorry, we over time. I didn't deliver in time. Sorry. And that would be it. Thank you very much. Dziękuję bardzo.